Everybody is welcome to my YouTube channel on the topics of B-tree deletion. Before going to the deletion of the B-tree, we want to discussion on the B-tree, details of the B-tree. B-tree is a MOA balance tree, and balance it means it is balanced because the value when we entering the key value of any node, it is initially it is a order system. A value is entering at the node and ascending order. So from left to right, the order value is increasing, and right to left it is already decreasing the value of the key value. Now, if the order of the B tree is M, if the order of the B tree is M, order is M, then children is M. Key of each node is M minus 1. Minimum children is M by 2. Minimum key M by 2 minus 1. In case of root node, the children, minimum children is 2. In case of root node, the minimum key is 1. All leaf node at same level. So this is a minimum criteria, minimum rules of the B tree, which is required to form a B tree, or insertion of B tree and deletion of the B tree is required. So B tree insertion, when we want to insert any value, any key value of any node of the B tree, then it is entering from via the root node or parent node of the B tree. So, and this is compared, we compare the value of the key, existing key, with the root node, and it is entered. Suppose the value of the key of any node of the B tree, suppose K1, K2, and K3. K1, K2, K3, and K1, K2, K3 is the 3 nodes, 3 key of any node of the B tree, where order is 4. When order is 4, that is 4 children can generate from of the node. And key is 3. Order is same, then key is 3. So this is the one node of the B tree, where value of the key is K1, K2, K3. K1 value less than K2, then K2 value less than K3. And if we see the another key of the, that is a left node of K1, suppose the value is K4, K5, and K6. And this is the left child of K2 value. Suppose the value is K7, K8, K9. and this is the left child of K3. Value suppose K10, K11, K12, K13, K14 and K15. This is the right child of K3. So value is arranged in this way. That is K4, value of the K4 is less than K5, less than K6, less than K1, less than K7, less than K9, 8, less than K9, and value less than K2, less than K10, less than K11, less than K12, less than K3, less than K13, less than K14, less than K15. This is the arrangement. This is the value flow from left to right. Value is increasing, and right to left it is decreasing. And so this is the flow of increasing of the value of the BTD. So leftmost node, where leftmost key of any node is showing the least value, and rightmost node of the key, rightmost key of any node is showing the biggest value of the key. So this is the flow of value of the node of the BTD. If we want to insert any value of the BTDs, first we compare with the root node of the BTD. So this is the root node. Suppose this is the order 4. So if the order is 4, then 4 children is generated from the node. So suppose the value I am entering 10, 15 and 18. C value I have already entered at the first node of the BTD. So that is 1, 2, 3, 4. 4 children will generate from this node. Most left node, suppose the value of the most left node of the 3 key. So key is 3. So I have to give put the value less value, that is suppose 2, 4, 5. Less value less than 10, and greater value of 10, that is 12, 13, 15. So I am turning this value 16, and this is the third child from left. Value is 17, 18, 90. So I have to change the value of this position. Suppose this is 25, and this rightmost child of the BTD 26, 28, 20, 30. This is the first level 0 and level 1, one BTD. So if we want to delete any value, how the value is deleted and what is the procedure to delete the value? If it is a leaf node, if it is a leaf node, then we can delete any value. So giving the description, we have to see that it is supporting the minimum key condition or not. Minimum key condition, minimum key is 4. Minimum key we have already shown that minimum key is 4. Minimum key is 1. Minimum key is 1. And why this minimum key 1 comes? Because order is 4. Then children is 4. Key is 4 minus 1, that is 3. Minimum key 3 by 2, that is 2. I have to take the ceiling value of the division of the fraction 2, and minimum means 2 minus 1, that is 1. So minimum key of this order 4 is 1. So minimum key, it is supporting already 3 keys there at this node. So 3 key, we have to delete any key, that is 5. Suppose I have to delete 5. So I can delete the 5 because it is supporting the minimum key condition. 3 key, already 1 is deleted. So 2 keys, rest keys, number of keys 2. So I can delete any node, any key from this node. That is, I am deleting 5. Now 2 keys left. So if we want to delete another key, suppose I am deleting 4, it is possible because 1 key is still now here, and also it is supporting the minimum key condition. Now I want to delete key number 12. This is the second right node of value key 10. And this this key 12, if we want to delete, we can delete because it is also supporting the minimum key condition. Minimum key is required 1 and it is showing 3 key, so it is possible to delete. Any arrangement to from another person or any bro from another node is not required in this case. So already supported by this. Next, if we want to suppose if we delete node 13, key 13, so we can delete also the 13 node. Now, if we want to delete the node 2, is it possible? No, it is not possible. Simply, I cannot delete the node 2 because the list minimum key condition will be invalidate, will be foul. So we can't simply delete the node key 2 from this leftmost node. So what we have to do, when we want to delete the node key 2 from the leftmost node, then the request from this node will be submitted at the parent node, and this node for the key. So this key, this node of now when existing only one key is 2, will request the parent node, that is 10, for one key replacement of this key. So replacement, where this replacement is possible, 10 will 10 this node 10 will take this borrow the node from the rightmost node. Rightmost node have no such extra key. It is also minimum key. So it is not possible from the to borrow node from the right child. So in this type, then this condition will occur. Then the merging is the only solution. I have to merge the key. The key means the leftmost key, taking rightmost key, and also the parent key. 3 key will be merged, and the after merging, we can delete also one key, that is 2. So if we want to delete the 2, that is from the node, leftmost node, we can delete this. But the merging 10, 15 is required for deletion of the node 2. So this node will be deleted, and 10, 15 will be merged, and it will be adjusted as a left node of node 16. This is a 16. 10, 15, 10 and 15. So this is the position of the now after deleting one node and merging. So 10, 15 is less than 16, and this portion also greater than 16, and this is the left node of 25. Also it is a less node, less value, and also it is a greater value of 25. Now if we want to delete those 19, is it possible? Yes, it is possible because this node contains 3 key and 1 key is deleted. So 2 keys, now rest number of keys 2. So it is not violating any rules of the B tree. So it is possible. Now if we want to delete another node, that is 18. Yes, is it also possible? Because one node is still now here. So not required any emergency that to borrow from any other node. This is the position. And now if you want to delete 17, what is the procedure? If we want to delete 17, then no key is existing at the middle node of the, that is right node of 16. Then 16 will request from the left node, from his left node, to borrow one element. So one element, that is 10, 15, immediate successor, that is immediate predecessor, you will take 15 because it is immediate left node, not 10. So immediate left node will be shifted to this at this place 16, and 16 will move at this place of 17. Then 17 will be deleted. So 17 will be deleted after coming 16. Come down 16 will come at this position, and 15 will take the position of the place of 16. So 15 will come here, and the problem is solved to delete the node of 15. This is the position, 15 will be deleted. So now if we want to delete again one node, that is 16. But at this node, again one key 16. So if we want to delete the 16 from this middle node, what we have to do? But this is a left node of 25. So he will send the request to the parent node for arranging one key. And this arrangement is only possible from the right node of the 25. And right immediate node is 26. So 26 will take place of the 25, and 25 will take place at the 16, and then 16 will be deleted. So 16 is deleted, 25 will come here, and 26 will take the place of 25. So 26 is appearing here, and 16 also, 16 was 25. 16 is coming, say 26 is coming in place of 15. Okay. And 26 will be replaced from this position. And number of node, one already deleted from this rightmost node of the 26. So two node is existing now, 28, 30, and leftmost only one node is 25, and 10 is the leftmost node of the 15. If we want to delete again that node 10, what is the position now? What we have to do? 10 is deleted, then only only one key, right key of the 50, 25 is there, and not possible to borrow from this middle node. Then these two nodes will be merged. 15 and 25 will be merged. 15 and 25 will be merged, and this will represent the left key of the 26. So when the deletion is occurred, the node which is deleted, the key which is deleted from any node, the node send a request to the parent node for the key, for any key which is required, which will be the replacement of the deletion node. In this way, request is coming at root node or parent node. So when any deletion or insertion is occurred, when any deletion is occurred, mainly the request, it will be via parent node. So deletion must be via parent node. Now this is the condition, and if we want to delete another node, that is, suppose we want to delete 28, no problem, because only one node still it will exist, that one key will exist, 30. So we can delete the key 28. After deletion of the 28, 30 is still now existing. So left rightmost node of the 26 till now existing one value of the key, that is 30. So we can delete 28. If required, if we want to delete further 30 nodes, then it is not possible. Mainly, simply it is not possible because there are no nodes and it is violating the B-tree minimum root condition. Then this, after deleting, before deleting 30, we have to arrange the another node from the left node, because we are showing two keys there. Two keys still now existing there. So one key, 26 will take from 25, because it is immediate immediate left node. So 25 will take place at the position of 26, and 26 will go there in place of 30. Then 30 will be deleted. So 30 will be deleted. 26 will take place here, and 25 will go there. Twenty-five. This is the position till now. So now, what is the condition? Latest condition, that is 20, 15, 25, and 26. But it is not required in this position, in this figure, because it is the level 0 and 1. Two level is there. We want to reduce the level, because each node have a capacity of the 3 key. So we can merge these 3 node in one node. So 25, middle position 25, 15, and then 26. Merging the 3 node, 3 key of the 3 node is adjusting. The new B tree, is formed, that is 15, 25, and 26. So deletion and merging is simultaneous adjusting process to delete any node of the B tree, and after adjusting, it is also required to look after that, to sync of the level, to minimize the level of the B tree, because level is proportionately depends upon the time complexity of the searching time complexity of the B tree. So this is the latest position. This is the latest position after deletion of the one by one. So the deletion of the BTD is completed. So this is the end of the video, and I am requesting everybody to subscribe of the channel for the new video.